My dear students, in my previous video, I have completed the topic applications of integral calculus, and we have solved some problems finding the area and volume of the curve bounded by the coordinate axis. Now, in this video, I am going to start a new topic, chapter number 10 in the State Board 12th standard syllabus, ordinary differential equations. Chapter 10, ordinary differential equations. In that, our first concept is order and degree of a differential equation. What do you mean by the order and degree of a differential equation? Before going to that, what is a differential equation? A differential equation is nothing but equations involving differentials. Differential coefficients are called differential equations. Equations involving differential coefficients is called a differential equation. Equations involving derivatives, I mean. Y is the dependent variable, x is the independent variable, dy by dx is the derivative, first derivative. The equations involving the derivatives are called differential equations. Examples of differential equation. Number 1, dy by dx equal to x plus y plus 5. This is an example for a differential equation. It consists of a differential dy by dx. Similarly, one more example, dy by dx plus d square y by dx square plus 3x equal to 0. This is also an example of a differential equation. Okay. And one more example, dy plus xy minus cos x into dx equal to 0. These are the examples of differential equations. So equations involving differential coefficients are called differential equations. These are the examples of differential equations. Our topic is we have to find out the order and degree of a differential equation. Our idea is solving of differential equation is our topic. Before going to solve the differential equations, first we are going to find out what is the order and degree of a differential equation. That is our first exercise in our textbook. Order of a differential equation is nothing but the highest order of the derivative existing in the equation. Highest order derivative. See, the order of a differential equation, the definition of order of a differential equation. Order. The order of a differential equation. Order of a differential equation is the highest. The order of the differential equation is the highest order derivative present in the equation. Present in the equation. The order of a differential equation is the highest order derivative present in the equation. For example, in the first equation, dy by dx is the highest order. Therefore, order of the differential equation is 1. In this first equation, the order of the differential equation is 1. The second equation, the highest order is 2. D square by dx square is the second order derivative is the highest order existing in the equation. Therefore, the order of the second equation is 2. dy by dx is simply the third equation. You will get dy by dx only, dy and dx only, first order. Therefore, order of the differential equation. This equation, it can be expressed as dy by dx equal to, this equation can be expressed as dy by dx equal to, you take that term to the right hand side, xy minus cos x becomes cos x minus xy. Cos x minus xy. So dx, you take that entire term to right hand side, xy minus cos x becomes cos x minus xy in dx, that dx, you bring it to the left hand side, it becomes the denominator. dy by dx equal to cos x minus xy. So order of the third example, order of the differential equation, order of this equation is 1. So, like that, the order of a differential equation is the highest order derivative existing in the equation, present in the equation. Here is the second order is the highest order, therefore order is 2. Here is only the first order, therefore order is 1. Here is also the order is 1. If you have so for example, suppose say, for example, d cube y by dx cube minus 3d square y by dx square plus 4 dy by dx equal to x cube, you can say. Here 3 is the highest order. Therefore, the order of this equation is 3. Order of this equation is 3. So, the highest order existing in the equation is the order of the differential equation. Third order derivative is the highest order, therefore, the order is 3. Like that, the order and degree of the differential equation. Order like that. Next, degree of the differential equation. Definition. Next definition. Degree. The degree of a differential equation. The degree of a differential equation is the degree of the highest order derivative present in the equation. The degree of the differential equation is the degree of the highest order. The degree of the differential equation is the degree or power of the highest derivative. The degree of the differential equation is the degree or power of the highest derivative present in the equation. See, the dy by dx of power 1, therefore the order is 1, degree is also 1. For this first example, order 1, the power of highest order is dy by dx is 1, therefore the order 1 degree 1. In this case, highest order is 2 and the power of this second order is 1. D square 1, d square by d square power 1. Therefore, order 2, the highest order derivative, the degree of the highest order is 1. Therefore, the degree of this equation is 1. Second problem, degree. Third one is order 1, degree is also 1. Third problem, order 1, degree is also 1. Fourth one, order 3, the highest order is 3 and the degree of this highest order is 1, therefore degree is 1. For third problem, order 1, degree 1. Like that, the order and degree are defined. So order means the highest order derivative present in the equation. The degree of the differential equation is the degree of the highest order derivative present in the equation. We will solve few more examples, few more problems in your exercise given in the textbook. We will see one by one. The textbook exercise 10.1, first exercise in the chapter 10. Find order and degree of the differential equations given. In what exercise 10.1. Find the order and degree of the differential equations given. Find the order and the degree of the differential equation. The first problem is dy by dx plus xy equal to cot x. dy by dx plus xy equal to cot x. See, in this problem, highest order is dy by dx, first order derivative only you have, and the degree of that is 1. Therefore, for this problem, order 1, degree 1. That is, you can write it as 1 comma 1. Similarly, second problem, d cube y by dx cube the whole power 2 by 3. d cube y by dx cube the whole power 2 by 3 minus 3 into d square by dx square plus 5 dy by dx plus 4 equal to 0. In this equation, the rational power should be converted into a whole number. This rational power is to be converted into a whole number. For that, you bring this d cube y by dx cube, you keep this term in power 2 by 3 on the left hand side itself. The entire term you bring it to the right hand side. That is 3d square y by dx square plus, this is plus become minus 5 dy by dx and plus 4 become minus 4. The three terms you should bring it to the right hand side, and taking cube, raising the power of 3 on both sides. This is power of 3, raising the power of 3 on both sides. If you raising the power of 3 on both sides, you will get, this is d cube y by dx cube, 3 cancel, you will get the whole square only, and the right hand side it becomes 3 into d square by dx square minus 5 dy by dx minus 4 the whole cube. See, in this case, highest order is 3 and the degree of the highest order is 2. By the definition, order of a differential equation consisting of the highest order is d cube by dx cube. The order is 3 and the degree of the highest order is 2. Therefore, for this problem, order 3, degree 2. Order 3, degree 2. For this problem, order 3, highest order degree is 2. Therefore, order 3, degree 2. This is the problem in your textbook. And fourth one is third problem. Find the order and degree of the equation root of dy by dx. Root of dy by dx minus 4 dy by dx minus 7x equal to 0. For this problem also, you keep this square root of dy by dx on the left hand side itself. You take the rest of the terms to the right hand side. It is 4 dy by dx plus 7x. Now squaring both sides. Square root is vanished. On squaring both sides, square root vanished, you will get dy by dx and the square root also vanished, you will get dy by dx only. Here, on squaring you will get 16 d square by dx, dy by dx the whole square. On squaring it is 16 dy by dx whole square, a plus b whole square formula. The square root and square vanished, and 16 dy by dx whole square, a square, plus 2ab, 2 into 4, 8, 8 7 are 56. 56x dy by dx plus 49x square. See, here order is 1 and the highest order is 1 and its degree is 2. Therefore, order 1 degree 2. For this problem, order 1 degree 2. Order 1 degree 2. Let's solve for this problem. Like that, you have to find out the order and degree of the differential equations given. And you consider the problem. D square y by dx square whole square. Second order derivative is the highest order, d square by dx square whole square plus dy by dx whole square. Equal to x into sine of d square by dx. For this equation, highest order is 2. Highest order 2. Therefore, order of this equation is 2. Degree does not exist because d square by dx square cannot be separated from the sine function. This is sine of the derivative d square by dx square is, we cannot separate this d square by dx square from the sine function. Therefore, we cannot define the degree. We can find out the order only. This 2 it does not imply the degree of the equation 2. Highest order d square by dx square is the highest order, and by the definition it can say that the highest order is 2 and the degree of the highest order is 2. Therefore, degree is 2, we can say that is not applicable for this problem because sine function consisting of a derivative, it should not be separated. Therefore, degree does not exist. Order 2, degree does not exist. Okay, no degree. Otherwise, order 2, no degree. That's the problem. And like that, if you find out a differential in a function, we can similarly log of some d square by dx square. If you find out the derivative within the log function, in that case also the degree we cannot define. For example, I will give you one more problem. See, find the order and degree of the differential equation. Example is d square y by dx square plus 3 dy by dx whole square equal to x square into log of d square by dx square. Here also d square by dx square cannot be separated from the log function, therefore no degree. Order is 2. Order 2. For this problem, order is 2. But d square by highest order is within the log function that cannot be separated, therefore no degree. This is all about the problem. Okay, and one more example. Find the order and degree of the problem. Y dy by dx equal to x by dy by dx plus dy by dx whole cube. Find out the order and degree of this equation. To find out the order and degree of this equation, you bring this denominator function to the numerator of the left hand side. You multiply the denominator function with the left hand side, you will get y into dy by dx into dy by dx plus dy by dx whole cube. you bring it to the left hand side and it becomes the numerator, that is equal to x. Again by multiplying y into dy by dx into dy by dx whole square, y into dy by dx whole square plus y into dy by dx into dy by dx whole cube is dy by dx whole power 4 equal to x. In this case, highest order is 1. Highest order is 1. But derivative and the degree of the highest order 1, derivative of the degree of this is 4. Therefore, order 1, degree 4. For this problem, order 1, degree 4. The degree of the highest order dy by dx is 4. Therefore, order 1 degree 4. This is the order and degree of the problem. And one more problem. Find out the order and degree. Seventh one is x equal to exponential e raised to the power of xy into dy by dx. See, in this case also x equal to e into xy into dy by dx. In this case also first derivative order is 1. But exponentiation consisting of the derivative should not be separated. Therefore, no degree. Order is 1, no degree for this problem. Okay. For this problem there is no degree, that's why dy by dx is in the exponential function. That cannot be separated. So that's all about the order and degree of these problems. I will stop here. We will continue the next topic in the next video. Thank you.